Here is the dealio. Here is one of my favorite functions in mathematics. It's a sine function. What? Cool. Doing its thing. It's great. Now, what's the period of sine of x? What is the period? It is 2 pi. That is correct. Now, Lil, what if Mr. Groom, I want to write this f of x. I hope that doesn't bother you. Lil, what if I said to you, what is f of 2x? Well, first thing Lil would say is, well, that's just the sine of 2x, Mr. Groom. And I said, okay, sure. Good job. Good job. You're not wrong. But what does that do to my graph? What does it do to my graph? Here's a hint. It doesn't shift it up and down. And it doesn't shift it left or right. It squishes it this way. Did you literally just do it with your hands? You are amazing. She literally did this. Yes, she did. Now watch. Now, you're like, Mr. Grimm, I don't remember that. Well, remember it. Okay? This is a big deal. So, it does this now, doesn't it? What? It's like the same heights. You know what I'm saying? It just does it twice as fast. Yes? Because it just squished it in. Now, Brooke, here's my question to you here. Suppose I wanted to do f prime of 2, well, let's just say f prime of, well, let's just say this is g of x, okay? So let's just do g prime, okay? That is, let's take the derivative of that guy. All right? Here's my question to you. So if g of x is sine of 2x, well, wouldn't it make sense that it would be something like cosine of 2x? That is, in other words, the derivative of sine is sine. I would heartily agree with you. Good job. However, remember, what is slope? Slope is by definition what over who? Who over what? Rise over run. Yes? Now look what's happened. We have squished it in like so. What have we done to the run? We've made it twice as small, half as big if you prefer, yes? And so if I take the same rise and divide by, I don't know, let's just hypothetically write in here, a half of the run, the slopes are going to be how much bigger now? 2 times bigger. Wait a minute. You mean it's literally going to be that? Uh-huh. But wait, does that 2 have anything to do with the 2x? It does. And what it is, it's clearly the derivative of that guy, isn't it? Yes? Nice. And so what we're going to see today is the whole thing about chain rule is this. You're going to have some h of x, I don't know. It's a function in a function. That's the whole point of chain rule. You have a function, well, in a function. Perhaps e to the 3x. Perhaps whatever. Sine of 5x. I don't know what it is. Who knows? If I have a function in a function, how do I take the derivative of it? Well, it goes like this. H prime of x is going to be equal to h prime of x is going to be equal to f prime evaluated at g of x. In other words, the derivative of the outside function times the derivative of the inside function. That's it. As hard as it gets. And it's all because up here you have squished the function in this case. But we did it with a 2, yes? Oh my gosh, Angel, it's a half. No way. Shut up, Mr. Groom. Half, and look at that, a half. Because what's happened? You have stretched that sucker out, and you've made the run twice as big now, haven't you? Meaning the slope is going to be half as big as it was previously. Now, all kinds of good ones like that. What if you had this function here? Half of x is equal to, I don't know, 3 e to the 2x. Oh, wow, look, there's a function, check it, in a function. Yeah? So the key here is who's the outer function and who's the inner function. To know this, right? Because remember on the previous page, we had an inner function and an outer function, yes? If you're not sure who's who, and some people have a hard time with this, I don't know why, it's just it is. So we're not bagging on you, we're just saying. If I told you what x is, what would you do first? You times it by 2. Hint, that's your inner function, and e to the x is your outer function, yes? All right. So f prime would be equal to 3 e to the 2x, because what's the derivative of e to the x? It's just e to the x. But what about the fact there's a 2x in there? Good. Leave it alone. Times, what's the derivative of that, fella? 2. So my final answer is 6 e to the 2x. And I am done. That is all.
So what if it was bigger than just...
Groovy. Like which one?
I didn't say like which one, but what if it was bigger than just 2 functions?
Oh my word, I will nest 3 functions later in the class period. But yes, you could have a function and a function and a function and a function and a function. Yeah, that gets creepy, dude. But we can do it. We'll do it. Not right now, but we'll do it. Now, you're like, wait a minute. What about this one? Lily really wants to do the square root of 5x squared plus 7 or something. I don't know why. That's what she said. We telepathically communicated just then. That's weird. All right. I feel like this is... Oops. No, it's not. I feel like it's that to the 1/2 power, isn't it? Again, if you're not sure who the inside function is, the inside function is where you'd start. So I told you what x was. You'd times it by 5. Or you'd square it, times it by 5, add 7 to it. That is the inside function. Literally inside the other function. So what's the square root? What's the derivative of the square root? It's 1/2 x to the minus 1/2, yes? Because that's a square root function. That's how we take the derivative of a square root. Times, what's the derivative of that inside piece? 10x, baby. What about the 7? What about the 7? What's the derivative of 7? It's not a. Now, can we clean this up a little bit? 10x wants to be where? Top or bottom? Where's this 10x want to be? Here's a hint. Is anything on top of it? No. Is there any negative exponents on the 10x? No. So where does it go? It goes on top. Where does that 2 go? I feel like it goes on the bottom. And where does this garbage go? On the bottom. And we might want to rewrite it as this. I'm just saying. Can we simplify it all, friends? I believe we can simplify it to this fella. Yay! And the crowd goes wild. Do you need a book? Oh, I'd loan you mine, but I forgot mine at home. So. Oh, okay. Stew about that for a minute. Yeah. Sure. All right. Now.
Oh, wait, that wasn't my question.
Oh.
My question was when we're solving for constants. When we're solving, we have to solve for a constant, right?
Where are we at?
So we just cross multiply this side.
Yeah, so you cross multiply. Yeah.
And then set it equal to 14.
Yeah.
Okay.
But yeah, you didn't need to do what I just did there. But you'll need to do that at the end. At the end, you would redo that because you need to write it e to the negative 2/3, right? But you wouldn't do that till the end. I wouldn't do that last step till I did till the end. All right, here's another one. What one? I feel like here's a good question here. Oh yeah, here we go. Weird. All right, again, inner, outer. Who's who? Who's who? Who's inner? 4x minus 2, because it's inside. It's obvious. Sometimes it's not obvious. This one's pretty obvious. If you can't figure out who's the inner function here, we need to talk. We need to get you schooled up a little bit. All right, so what's the derivative of ln? It's 1 over x, yes? So in this case, it's going to be 3 over the inside function. right? Because the derivative, remember this? The derivative of the ln of x is 1 over x, yes? Right? So, all I've done is said, well, my x now is a function is all. Yes? There's 1 over that. Times, what's the derivative of this inside piece? 4. So my answer is literally just 12 over 4x minus 2. But the back of the book says it's this, Mr. Groom. How come? How come?
Simplify.
What is it? Everybody's got 2 in common, yes? Alright. You want one of these deals out of there? Alright. So, does that work for you? Is that okay? Everyone's got a 2 in common? Alright. Zach, here's a question for you. Because, that's what I do. I've been asked to do one that's a function in a function. In a function. By the way, this might be an excellent question. Might be an excellent question for a test question. Listen, is there any, on this question, is there anywhere, or what's the domain of this function? Well, I feel like we're good as long as as long as the sign doesn't equal 0, yes? But the sign equals 0 quite a few places, yes? So we're probably going to end up with an asymptote, aren't we? Crap. That's weird. Here's another question for you. What is the sign? It's always less than or equal to 1, yes? Well, if you take the absolute value of it, right? What's the logarithm of a fraction? Positive or negative? Ask Betsy. Go ahead and ask Betsy. Ask her. Oh, great, glorious Betsy. Ask Betsy. For God's sakes. What's the ln of a half? For instance. Rookies. Amateurs.
It's negative.
It's negative. Ha! Matter of fact, they're all negative, except at 1, when the sign is going to equal 1, we're going to have a 0, yes? Because the ln of 1 is 0. Interesting. But anyway, I digress. So when I think about this thing here, I think the sign of 2x minus 3 had better not be negative. Oh, but I got that took care of because I got absolute values, so we're good to go, yes? However, it better not equal 0, right? And it wouldn't really equal 0. It'll equal 0 when you're over here at 0 or you're over there at pi and back and forth and back and forth. So there's quite a few times that'll happen, yes? So when I get done in a few minutes, I'm expecting to see a bunch of asymptotes, aren't I? Further, I'm expecting to see probably something that looks like this is what I'm guessing, probably, headed towards asymptotes, always negative because the ln of a fraction is always negative. Now, I mentioned that just so when we see the graph in a few minutes, everyone's like, oh my God, I'm surprised, because you shouldn't be surprised by that. Okay, I hope. Right now. All right. Who's the innermost function here?
2x minus 3.
Well, I was talking to Zach, but that's all right. Zach. Okay. Ooh, wait, but that's a function in a function. In a function. So, here we go. We start with the outside. One over sine 2x minus 3. Mr. Groom, what happens to that? Do I need to have these guys here, Mr. Groom? Are they necessary? I'll leave them for a minute and I'll let you decide if they're necessary. Now, times. What's the derivative of the sine function? Cosine. Cosine of who, you ask? Well, 2x minus 3, of course. Hey, what's the derivative of 2x minus 3? 2. So, check it. It feels like this might be my answer. Well, I don't know if I need those or not. Let's go ask Desmos. See what she thinks about it. Oops. Ah, boy, I feel terrible. All right. All right, read me the original.
X equals ln of the absolute value of sine 2x base 3.
Plus 3?
Minus 3.
Minus 3. Ooh.
Whoa.
Dude, am I shocked? You know I'm not. Not terribly shocked because I figured it'd have asymptotes. It does. Oh, look, they're all negative. Geez, I'm shocked. I'm not very shocked by that, I don't think. All right. So that makes me happy. Look at all the slopes. Are they all positive? Are they all negative? Do they change? I feel like they're positive on their way up to here. And then I feel like they're negative again. By the way, what's the slope right here? What is the derivative right here? 0. The max, yes? Now, here's my question. Let's graph our supposed derivative. What did it come out to be? 2 sine?
2 cosine 2x.
Hold up. Oh, I can't do that fast.
Over this absolute value of sine 2x.
What?
Sine 2x minus 3.
Oh. What? What? Uh-oh. Uh-oh. Now, we said that in here we had positive slopes, yes? But the blue line is my slope, yes? Blue line's negative. Uh-oh. That's weird. Now, let's fix that, shall we? Let's lose this absolute value crap. Let's see what happens. Oh, es muy bueno. See? No? Positive slopes, yes. Describing the red graph. 0 slope here. Negative slopes. Oh. So you'll remember, we did this the other day. We said that the derivative of the ln of x. Now, we didn't put the absolute value on that today, did we? We're like, what? Because this guy is defined to be, only greater than 0, yes? Right? Because it only exists there. So we said that the derivative is 1 over x, but remember, that's when x is straight up positive, yes? So it's inherent because of this, that this guy only we're talking about there. But, and this is a big but, I mean this is a large posterior. What if you had, it's that's like a pop star's sized posterior, if you will. Where is this one defined? I feel like this one everywhere except 0, eh? Right? Hey, I don't remember what that looks like. We should go graph him. ln of the absolute value. Oh, you hippie. Thank you. What? Oh, look, he exists on both sides. Notice. On this side, it has positive or negative slopes over here. Negative slopes and positive slopes. Interesting. Now, watch what happens. What if I took the derivative of it and did 1 divided by x? What? Lucky there. So 1 over x on this side, this purple is describing the slope of this line. It's all negative. Over here, they're all positive. So, what we should have done is this. Over here, when we did the derivative, we say this is just straight up 1 over x. And again, that's where x does not equal 0. Danger Dan, is that you making all the racket back there? Try to eat quietly, son. Good grief. It's fine. There you go. Okay? And that's how come. Now, please note that the calculator cannot tell me the answer, but it can tell me if my answer is correct or in the ballpark. Okay? And it's pretty quick to note. Because I go back and look at that graph, I'm like, geez, these slopes are like completely opposite what they're supposed to be. Oh, whoops. All right? And then look at it. But again, this is something you should write down. When we state this, when we state that to be the case, we are inherently saying that a derivative is only on the positive side. Okay? When we're taking this guy here, it is domain is everywhere but 0. And 1 over x is everywhere but 0 as well. Okay? By the way, just for fun, in second semester when we start doing integrals, I don't know what that means yet. Yeah. We undo derivatives. We anti-derivative. No kidding. That's what they're called originally. Anti-derivatives. What do you suppose the antiderivative of 1 over x is? It's not just natural log of x. Because if you see the function y equals 1 over x, what's the domain? It's all numbers but 0. So what's the antiderivative of this? It's the ln of this fella. Okay? Because it's all about the domain. Okay? So I mentioned that because with the absolute value up here, on that previous problem with the sign, it mattered where we were at, yes? Now, what would have happened? Oops, I forgot to, I want to do that. What was the original? Read me the original again. What was it? But not all of it. So it's the ln of, but I'm not going to do this, I'm not going to do the absolute value this time. So just sine of.
Sine 2x minus ax plus b.
Shh. Ooh. I feel like I'm missing part of the graph here. What's going on? Oops. What is going on? In between here, what is going on, yo? I feel like that's where the sign is negative. What's the ln of a negative number? It doesn't exist, yo. So in this piece in here, there's regions where it doesn't exist. If you put absolute values on those suckers, bam! There they are. So be aware of that. Okay? Alright, somebody pick me a function. Something cool, something interesting. Connor, pick me a function. Pick me a function, man. Sine, cosine, do something different. I'm bored of those.
Tangent.
By God, that's right. Tangent of who?
2x.
Oh, I'm tired of 2x. Let's do something different. Let's think outside the bun a little bit. What?
13x.
13x.
Minus.
That'll piss Levi off.
So dumb.
Just to see if you're paying attention. Oh my gosh, look, it's a chain rule. Huh? Would you answer that? See what she's calling me for in the middle of class? And then look over here. Look over here. Product rule, right? But with 2 chain rules. Who is it?
I answered, it's not there.
Who? Oh, nobody? Oh, freaking, what did he mess up this time? Who knows? All right, so let's start off with the tangent piece. By the way, these are all limits, so I do them whenever I feel like doing them, yes? Do this one piece here first. What's the derivative of tangent? I don't remember. Look it up. Secant squared. Of what? Well, of this mess. Right? Times, now what's the derivative of this inner mess? Bam. So the first part is finito. See. I'm in a weird mood. It's the snot. Now let's look at this piece here, shall we? Plus. What's the derivative of this thing? Well, you have to do product rule first. So what's the derivative of e to the 2x? What? Say it, Hannah. Say it, woman. Let's go. Well, listen, you're not wrong as far as you've gone. E to the 2x times the derivative of 2x. I know. That's right. That's the derivative of the first, yes? 2 e to the 2x times sine of x minus 5, right? Because it's the derivative of the first times the second, yes? Plus the first times the derivative of the second. Now, what's the derivative of sine, Angel? Cosine. So cosine of x minus 5. And what's the derivative of x minus 5? 1. By the way, just as an aside, if you do sine of x minus 5, all you do is slide the function sideways, yes? Did you change how fast it goes up and down? So when you take the derivative, you'd expect it to have the exact same slopes, yes? But they happen in different places, yes? So it's the same thing. You've just taken the derivative and just slid the derivative over 5 too. That's it. Yay! All right. Now, can I do anything with that mess? Not really. That's probably just as good enough to leave it that way. Couldn't I factor e to the 2x out? If you're weird and want to, sure, but that seems odd. I don't think I'd do that. I mean, if you're weird and you want to do it, you knock yourself out. But I think I stop right there. That's what I do. Sure. What if, check this out, what if you had the ln of 3x minus 1, 4x minus 2? Oh my gosh, it's a quotient rule inside a chain. It's exciting. So what is the derivative of ln? What is it? 1 over x. So it's 1 over that whole inside thing. Which if you're good with fractions, you know flips it upside down. We'll do that in a minute, okay? Times, what's the derivative of this inside piece? I take the derivative of quotient. By the way, we were probably due for a quiz pretty soon. Derivative of quotient is how? What is it? Yes, so the derivative of the top, which is 3 times the bottom, minus the top times the derivative of the bottom over the bottom squared. Nice. Hey, let's just times this out. 12x minus 6 minus 12x plus 4. Look about right? Yeah, buddy. So negative 2 on top, I think. That looks stupid. Do a better job. You freaking loser. Now, what happens to this mess over here? It just flips upside down, yes? Brooke, can I do anything with cleaning that mess up at all?
Wait, for the first part?
Can I just finish cleaning that up at all? There's a multiplication problem, you know. And I'm left with negative 2 over 3x minus 1, 4x minus 2. This is our derivative, yes? Question. Where does this derivative have a problem? Where does it have a problem? It has issues at 1/3 and 1/2. Yes? Now, I understand why it has a problem at 1/2, don't you? I feel like I get why it has a problem at 1/2. Yes? Because it's 0 in the basement. Why does it have a problem at 1/3? Because 1/3 would cause the numerator to be 0, yes? Which would cause the whole thing to be 0. And what is the ln of 0? It's undefined. It's undefined. So sometimes you're not noticing it at first, and then you're like, oh yeah. So here's a question for you. So you're telling me that you think the function is defined everywhere except those values. I'm telling you it doesn't. Let's go look at it. Just see what's up. So the numerator is this. What is it? 4x minus 2? Oh. So there we go. Hey, look, there's x equals 1/2. Duh. Yes, there's our asymptote, just like we thought. And we also said there should be a problem at 1/3, right? So if you come along here somewhere, right there, well, Okay, well, let's do this. And Mr. Green, why aren't they connecting? Because they won't connect because the point is there's a big fat hole in this other function is what I'm trying to say. And where is there a big hole? Well, somewhere along in this mess. No, there's asymptotes at a half. That's what the denominator is equal to 0. Oh, right there. Ooh, that's a problem, friends. That is a big problem. Do you see what that says right there? It says 0.333. It looks like a third, right? Here's how I know. My point is this: the only function that I have the only number that I have a problem with is when it's equal to 0, or when you're dividing by 0. You're dividing by 0 at a half. It's equal to 0 at a third. For God's sakes, would someone answer that? That's ridiculous. Now, so let's do this. Let's go ln.
Well,
Oops. Oops. So such that x equals 1/3. Ah, undefined, yes? Right? Now that's actually weird because you're putting in 0, but you're putting in negative 1/3 or positive 1/3, and you're getting that it comes out to be 0. The ln of 0 is negative infinity. Yes, it's headed toward infinity. But what if it was a number that's slightly less than a third? Yeah, negative 11 or something. Okay, that's great. What if it was a number slightly bigger than a third? Ooh, that's imaginary. That's a problem, yes? Weird. That's odd. I wonder what that's about. Ooh, interesting. You may have a point, son. You may have a point. Ooh, creepy. Even better. That's just creepy, friends. You know what we need to do? We need to change our window a little bit. Creepy. Let's make our x go from 0.3 to 0.5. Oh, I'm going to die. Yes, indeedy. I need to go out a little bit. Darn it. Darn it. Why isn't it showing up there? Why aren't you showing up there somewhere? There it is. You see it? There it is over here. You see it? There it is. You see it? Huh? But Mr. Grimm, what happens between 1/3 and 1/2? Nothing. What happens in there? There's just a void in there. You see that? Nothing happens between those values. And once in a while, you run into a situation where the graph's not obvious at first, but what a person can do, if they wanted to, is to make a number line like this. Obviously, we can't have these values, yes? Pick a number that's bigger than a half. I don't know, 10. Cool. The top's positive, the bottom's positive. Positive divided by positive is a positive. Can you take the ln of a positive number? I feel like you can. It's good. What happens if you pick a number that's between a half and a third? Like 0.4. Positive on top and negative on the bottom. Ooh, that's a problem. You might want to check a few of them in there. Oh, they're all problems. That sucks. What if you pick a number that's less than a third? You mean like 0, Mr. Grimm? Cool. So negative 1 divided by negative 2 is positive. You take the ln of a positive number? You sure can. Alright? So what happened here is between those values, we have a lot of do not exists. Well, if the function doesn't exist, what else doesn't exist? The derivative can't exist, yes? We have positive slopes out here. We have negative slopes over here, but they exist, but they're just negative slopes. Well, that's fine. You will, from time to time, run into something that's just gross like this. Not very often, thankfully, but every now and again. Nice. And by the way, you're right. This should have been a problem here. I should have caught that a second ago. I didn't catch it. It wasn't an asked on the original problem. Well, it is. It is. It's not so obvious that it is on the original problem, I should say. Okay, now, that is what you're going to be working on from this section. The section, whatever section it is, chain rule in your book. Not next week, of course, but the following week, I expect you to have some good questions. I will be here on Monday and Tuesday for 16 hours twiddling my thumbs.